In this lesson, we'll be taking a look at ellipses, the next conic section. Ellipses and circles are very similar, so that's why they are both on this same set of slides here, but the ellipses are all that we're going to look at today. So for the ellipses, we have this picture here. Please do not call it an oval. It is not an oval. An oval is not a mathematical shape, just like a diamond is not a mathematical shape. It is an ellipse. It has a lot more parts going on than previous conic section parabolas. We do have some similarities though, especially in terms of the formulas. So for this, we have a center, it's right in the middle there, and then we have a focus, but we have a second focus. So we have two foci here, and we do have vertices on both sides as well as co-vertices. So we're seeing some of the same terminology that we saw in the parabolas, and we now have some new terminology as well. So what's going to happen with these is they're going to be directionally based. You can get that information from the formula, much like the parabolas. This one is opening longer on the x-axis, the picture that I've drawn here, and shorter on the y-axis. We can have that the other way around, where it's longer on the y-axis and shorter on the x-axis. And again, that's all going to be determined by the equation. Before we go down to those, we just need to talk about the rest of the parts here. So the center has a distance that is a to the vertex, b to what's called the covertex, and c to what is the focus. So we have those three different values that we will be calculating in our problem, and those are all listed out here. A is the distance from focus to vertex, b is to center to covertex, and c is distance from focus to center. I think I have those. This one's wrong here. This should be from the center to the vertex. Okay, now we're good. So we have all those matching the picture now. We have the equations down here, and they are going to be pretty much the exact same like the two equations for parabolas were. The only difference is going to be where we use these numbers from that. So this first side here on the left, we have the horizontal axis is the major axis. So that means it's going to be longer on the x. That's all that this means when it says horizontal major axis. It means it's going to be longer on the x. And once we have numbers, it's going to be very apparent which has the longer axis. We don't really need to worry about denoting that. So the y equation over here for the vertical major axis, the only difference between the two equations is where a and b are. So a is going to be the longer axis. Here it's under x, so that's horizontal. Here it's under y, so that's why it's vertical. So wherever the bigger number is on the bottom, that's the longer direction, x or y. So the center is the exact same, h and k. That's easy. The foci is whatever the major letter is plus c. So on this one it is x because that's the major horizontal axis plus c. Over here it is y plus c. And then the vertices are the same orientation, so plus a now to h, or plus a now to k, because that is the distance from the center to the vertex, like I changed up there. The major axis is just whatever the repeated coordinate is here, so the h is the same there, so that is the major axis, or sorry, wrong way around. K is the one that's unaffected there, so that's the major axis. Forgot to mention covertices. Covertices are the other letter, so now k plus b, or in the y version, h plus b, major and minor axes. Then we have the equation down here for c squared. And this is the one place where people are like, wait a second, that looks familiar, but that's not right. This is not the Pythagorean theorem. It's not trying to be. It's unfortunate they use the same letters and the same sort of setup with only one very slight difference. This is not the Pythagorean theorem. C squared is a squared minus b squared. This is the equation specific to this shape, the ellipse, and it doesn't mean anything else. So we do need to know this separate from the the Pythagorean theorem. Don't try to do the Pythagorean theorem for this. That's not what we're doing. There are no triangles in this picture. That's not the relationship we're setting up. Okay, so with all that in mind, we are going to go through these, and the goal is for these problems to graph it And if it's not in this, what I call vertex form, this is what we see right here, where it has the setup the same as these. If it's not in this form, we want to get it into that form. So for this first problem, it is in the correct form that we want. So we really just need to get the information, these 7 or so pieces of information, and then graph it. So the first thing we're going to do is to find the center. That's the most important. Just like in the parabolas, that was the vertex, now this is the center. That is going to be the numbers that are with x and y, but the opposite signs. So the number with x is -3, which means the center is going to be +3 for the x coordinate, and the y is with +1, so opposite, so -1. So there's our center, 3, -1, which means that h is 3. So that's just kind of a side note, h is 3, and k is -1. And that'll be helpful for what we're about to do. So the next thing to do is to find the foci. And in order to do the foci, we need to know this value c. That's what we're adding. So we need to find c, which we have the equations for right there. That's the next step. Okay, another small thing with this, the numbers on the bottom are technically squares. So it's a squared and b squared, which means that a is not 36. A squared is 36, and b squared is 9. Oops. So we can do one of two things with those pieces of information. We can either say, okay, a is 6, and use that, and b is 9, which we'll need those numbers, and that's pretty easy to do. Or it's okay to leave them like that because we're about to use them in this c formula as squares. So whatever you need to do. So there's a squared, b squared. Now we're going to get c, and I'm just going to go straight to this part of the formula. C is a squared minus b squared. So c is the square root of 36 minus 9. So c is the square root of, that is 27. Feels weird because 27 is not a perfect square. That's okay. Most times these c values won't work out to be nice perfect squares, and that's absolutely fine. We don't need any specific values to come out. Whatever the problem dictates, don't try to force it to be a perfect square like I've seen a lot of people do. Oh, 36 minus 9 is 25 because that's a perfect square. It's 5. No. Make sure you do good algebra. It's okay if it's not a perfect square. C doesn't really do too much for us. The foci, it's not a huge deal if we don't have exact numbers on those. So that's what C is, which means our foci are at H plus C. So H is 3. So we'll do 3 plus or minus the square root of 27, comma -1, since we have two foci, plus or minus. Just leave it like that. There's no point in getting a decimal. We know relatively where those are going to be. They're going to be in between the center and the vertex. So just leave it like that. All right, I'm writing apparently too big here. That's okay. The next thing is the vertices. So that's h plus a. So I'm just going to go back up here so I can leave some space down at the bottom of the graph. So verts are at h plus a. So h is 3, a is 6. So 3 plus 6 is 9, -1. And then we'll do the subtraction. So 3 minus 6 is -3, -1. The covertices are at h plus b. Sorry, k plus b. We're moving on to the y coordinate. So coverts are at 3 and then 1, -1, sorry, plus 9 is 8. And 3, -1 minus 9 is -10. I did that wrong. B is 3, not 9. Square root of 9 is not 9. Change those really quickly here. So we should have -1 plus 3, that is 2, and -1 minus 3, that's -4. Those look better. There we go. So covertices, major axis is just y equals k. So that's y equals, the k value is 3, and minor is x equals the, gosh, I keep doing this all backwards, -1, y equals k, and then x equals h is 3. First problem of the day, bound to have some mistakes. All right, so we're good to go there. All this information is great, but the information that we want to graph this is really going to come from the original equation. So if we look at this, we are going to plot the center, we are going to plot the vertices, but we can do that very easily from the equation. So why are we doing all this stuff? Well, it's nice to have it listed out numerically and to go through this process, but we can get the bulk of the information that we need right from the equation. So the first thing we're going to do is always plot the center. So we go over to 3, -1. So we do need to have an awareness of where that is. 3, -1. And then to plot the rest of this, what we're going to do, and this is super easy, is just count to make 4 more dots. So we're going to do a dot above, below, to the left, and to the right. So basically what we're going to plot are the vertices and co-vertices. And we're going to do that without doing all of that extra math. So I know what they are. I'm not going to look at that, but here's how we would do it. So we take the x and we go in the x direction, and we go whatever the a value is. So our a value is 6, so we're going to go 6 to the left and to the right. So 1, 2, 3, 4, 5, 6, make a new point, and then to the left 1, 2, 3, 4, 5, 6, and make a new point. Stop really quick and check. Those should be at 9, -1, and -3, -1, and they are. This is at 9, -1, and the other is at -3, -1. So that goes along with what we found. For the other 2 points, the co-vertices, we're going to take the b value and go up and down by that. So up and down 3. So 1, 2, 3 up, and 1, 2, 3 down. So those are kind of what I call the cardinal points, I guess, if you think about like a compass, north, south, east, and west. Those are the 4 points that we need to really draw this ellipse correctly. Those are the vertices and co-vertices. If we really want to get technical with it, we can plot in the foci. So square root of 27 is a little bit more than 5. So these are going to be pretty close to the vertices, and that's okay. It's kind of a narrow ellipse. So if you really want to, there's somewhere in here. I'm not going to do it. But the numbers, the points that we need are already graphed. Now when we connect the dots, we need to do this in a way that makes it look like an ellipse. I've seen a ton of these that look like kites, rhombi, even squares, rectangles. Please, please, please draw with a curve. And if you need to sort of take a few attempts at it, that's fine, but it needs to look somewhat curved. If it looks like a football, I guess we're in the right ballpark. But depending on how accurate you made your axes, that is also going to determine how good of a shape you can make. So mine kind of looks like a nice potato, which is a good shape for it to be. So there we go. It's not a perfect drawing on there, but the points are where they need to be relative to the tick marks on the axis. So that's what we're going for. Okay, so that's the first one. That's the easiest we can have, is that bit of information: get A, get B, plot the center, count up, down, left, and right. This is the hardest version of the equation that we can get. So this is kind of the standard form of it, where it's a quadratic, more or less, with x's and y's, and this will require the same steps that we had for the parabolas when we had an equation in standard form. We are going to have to complete the square. We're going to have to do it twice now for both of the variables, because both of the variables are squared. It's a super easy process. Again, I'm not a fan of it, but it's not hard. So what we want to do with this, whenever we've got a standard form for any of the remaining conics, there we go. We are going to always take the constant, move it to the right side of the equation by itself. So this 24 needs to go. And then we want to collect the x terms together and the y terms together. So that's the first step that we're going to do. We're going to move that to the other side, get these 2 y terms together, and get these 2 x terms together. So we'll have 4x squared. The negative stays with the 24x, plus y squared, plus 4y, equals -24, because we're going to subtract that to the other side, so -24. Don't freak out that it's negative. It'll work out. We'll be okay. All right, so we have this now set up in a way that we can do the completing the square. So what we want to do before, one last step before we go to completing the square, is the coefficient for the squared terms needs to be 1. And if it's not, we need to factor something out. So for the y's, we're good because it's 1y squared. But for the x's, there's a 4. So we need to factor 4 out of both of those. So we have 4 quantity x squared minus 6 now, plus, it's still just y squared plus 4y equals negative 24. Okay, so we have the setup that we need for completing the square. Now all we have to do is complete the square, and we need to do it twice. Again, super easy process, very orderly, do the right steps, and you're good to go. It's going to be the b term, which is the number with the single variable, divided by 2, and then we're going to square that, add, and subtract. So here, that middle b number would be 6. So half of 6 is 3, and 3 squared is 9. So that's what we're doing here. I'm going to write it off to the side because it's really not part of that work. But b is 6, negative, whatever. So b over 2 is 3, and then that squared becomes 9. So we're going to add and subtract 9. So we'll have 4 quantity x squared minus 6x plus 9, and then we're going to immediately subtract the 9. We're going to do the same thing for the y. This time that b term is 4. So 4 divided by 2 is 2. And when we square that, we're going to get 4 again. So plus 4y plus 4, and then immediately minus 4. Okay, so the next step is to get the negative out of each of those squares. So we need to get this negative 9 out and this negative 4. And what we're going to do is just immediately add them to the right side of the equation. So we're going to get them all the way to the other side because that's where we want all of our constants to end up that we don't need is on that right side. For the x number, we do need to remember that when it comes out of this, it needs to get multiplied by the 4, this 4 out front. It's the only little kind of exception here with that one that's different than the y is it needs to get multiplied by that 4 out front. So 4 times 9 is 36, and when we bring that over to the other side, we're going to add 36. Okay, and then when we do the same thing for the 4 here with the y's, there's nothing to add or multiply, excuse me, so we just add 4 over. That's going to leave us with 4x squared minus 6x plus 9. We took that minus 9 out and took it to the right side of the equation, plus y squared plus 4y plus 4. And again, we took that 4 out and we moved it to the other side. So there we go. Now we're ready to factor. So what these should factor to is the variable, then whatever the first sign is, positive or negative, and then the root of whatever this final number is. So this first parenthesis should be x. There we go. X, that's a minus sign, and then the square root of 9 is 3. That's again the number that we found up here when we did b over 2. That 4 is still there, plus, and then y, that's a plus sign, and then the square root of 4 is 2. And then if we add all of this together, 4 plus 36 is 40. 40 minus 24 is 16. So a little bit of way to check yourself, I guess, I don't know, it's not like a cheat or anything, is the number that's on the right side. It should be a perfect square and or divisible by the coefficients on the other side. That's the bigger one, is it needs to be divisible by the two coefficients on the other side. So 16 is a perfect square, that's awesome. 16 is also divisible by 4. So perfect square works out, that's great for us, and then divisible is even better. Okay, so the last thing we're going to do, and if we go back up to these formulas, they are both equal to 1. So the last step we need to do is divide by whatever this number is over here. So it's 16. We're going to divide everything by 16. So it gets equal to 1. And we do want to reduce. We don't want to leave a number on the top. If you notice, there are no coefficients on any of the fractions on the numerator. So we are going to get the x minus 3 quantity squared over 4 divided by 16. So we get 4 on the bottom plus y plus 2 quantity squared over 16. Okay, and there we go. I'm going to graph it really quickly. If you want to pause and take a go at it, you can. Okay, so hopefully you've had a chance to graph it. I'm not going to list out all of the parts. If you want to go back up through and do that, we now have all that information. So like A is under the Y because it's the bigger number. So A is 4, B is 2. You can get C very quickly from that. I'm not going to go through all of that. C would be like the square root of 12. Okay, so all I'm going to do is graph this. So I'm going to start by plotting the center. The center is at 3, -2. So very similar to the previous problem. Okay, in the x direction, we're going to go whatever this number is, the square root of that. So the square root of 4 is 2. So I'm going to go 2 to the left and 2 to the right. So this is a pretty tight ellipse. For the y's, I'm going to go whatever the square root of that is, the number below the y, up and down. So the square root of 16 is 4. So I'm going to go up 1, 2, 3, 4. And I'm going to go down 1, 2, 3, 4. Okay, so there we go. It's a very small ellipse, and that's perfectly fine. And then we're going to play connect the dots with a rounded segment here. All right, there we go. Nice and round-ish. And that's our ellipse. So this one requires a bunch of setup work, again, with the factoring and completing the square to get it into the vertex form, but then it's the same from there to find the rest of the pieces that we need. Okay, trying to keep this short, so I apologize if I'm going a little fast. The last one here, the last example we're going to do, they're going to give us the, what they say here is the major axis, blank to blank, the minor axis, blank to blank in the center. What they've actually given us are the 5 points that we need to plot this. So they've given us all the details we need to plot this, and then we're just going to go through and write out the formula from it. So the first step here is to actually graph, and that is awesome because we get the visual before we do any of the hard work. So what we're going to do is we're going to make our big XY here. The first thing we're going to plot is the center. So -1, 2, 3, 4, 5, 6, down 1, 2, 3. There is our center. So I'm going to have to extend a little bit further this way, but that's okay. Now what we're going to do, we're not going to worry about what's major, what's minor right now. We're just going to plot these 5 sets of points. That's all we're going to do. So we've already plotted the center, so I'm just going to work kind of backwards here. So the next point to plot is -9, -3. So that's 6, 7, 8, 9, -3. And then -3, -3. So 1, 2, 3. Then I'm going to graph -6, -8. So that's 3, 4, 5, 6, 7, 8. And then -6, +2, 2. Okay, so there is our ellipse. This one's a little bit more challenging for me because it's a little bit boxier, a little bit more of square dimensions. So the x and the y distances are pretty close. But there we go. We have our ellipse without doing any math at all. We just plotted points, which is something we've been doing for many, many years. So now we need to go back and actually write this equation. And this is probably the easiest version to write the equation from. It might be the easiest overall that they can give it to us, even though it looks kind of confusing with this major and minor stuff. So again, we're not going to worry about those words major and minor axis. All we're going to do is we're going to take the information that we've now plotted and then put that into the equation. So it's going to be a fraction plus a fraction equals 1. That's what it always is a fraction plus a fraction equals 1. So it's an x fraction, a y fraction equals 1. So the first numerator here is going to be the x, and the second one's going to be the y. So what goes in those parentheses? Well, it's the center, and it's the opposite sign. So if the x part is -6 here, we're going to put the opposite in the parentheses with the x, so +6. Close it, square it. Same thing for y. It's -3 here, so we're going to put the opposite in, so it's +3. Close it, square it. Okay, now we're going to go to our graph and we're going to count how far left or right we went. So we were here in the center, we went 1, 2, 3 to the right. That's 1, 2, 3 to the left. So that is our x distance. To this problem, it's going to be technically be b value. So what we do with that is we just square it. So 3 squared is 9, and that number goes below the x. And then we're going to do the same thing for the y. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A little harder to do that one. But the y distance is 5. So we're going to square that, and we get 25, and that goes underneath the y. And there we go. We have a vertex equation. The counting of the distances harkens us back to like really basic algebra stuff. So we should be pretty good at counting that, and then we just need to square it to put it under the correct fraction. Again, I'm not going to go through listing out all of the other parts. We already have most of the information we need. Like when it gives us major axis, what they're really giving us are the coordinates of the vertices. That's what they're doing. When they give us minor axis, they're giving us the coordinates of the covertices. So we already have major, we already have minor, we already have center, we already have what A and B are. So the only thing that we're really missing on this is the C value, which gives us the foci. If we go look at all this, we had the center, we had the vertices, covertices, major, minor. So the only thing we were missing there was the foci. And the foci are the least important part of the work that we're doing. They are an important part of the um, ellipses, but for us, we're not going to do too much with them. So there is a really cool sort of, I don't know, I think it's cool. It's like a fourth grade art project, really. But visualization you can do with this. If you have something that you can push 2 pins into or 2 magnets on a whiteboard, it's impossible to do on this surface. I'm sure you could search it and you could find videos of it. But basically what you do is you just take 2 fixed anchors, you put them somewhere, and then you take a string that's longer than the distance between the 2 anchors and tie that string kind of to both those anchor points. You'd slip a pen in it, and when you do that, with the string, there'd be some slack in the string, and what would happen is you would trace it and it would pull taut and you would make an ellipse. You'd make the top half, reorient the pen, and then you would make the bottom half of the ellipse. So if you're curious to see that, I don't really know exactly what you would search, like how to draw an ellipse using foci. It might come up with that. It's something I did, I don't know, in middle school, but it's a really cool way to see why we care about those vertices, especially since I've not really focused on them as much in this lesson. Sorry, that's a terrible joke. But yeah, that is the gist of what we need to do. So to find the 5 critical points here, the center, most important, the vertices, the covertices, graph them. It is a good idea then to list out the rest of the information like we did for the first problem. Got a little lazy on the second and third, but this is how we want our work to look with the center, the foci, the vertices, covertices, major and minor axis, as well as A, B, and C, all listed out a little bit, hopefully neater than I did it. But that'll do it for ellipses. In the next video, we will take a look at a very special ellipse, which is a circle. But until next time.